Alright, hello and welcome to another physics tutorial. So today we will be looking at problem number 24 in chapter 15, which covers oscillations. So let's look at our question. So we have a block that's attached to two springs that are attached to each other, and each of these springs have spring constant K. And we see that this block is set oscillating, and we want the frequency of these oscillations. So our first step is to set these two attached springs equal to another equivalent spring. So we have one equivalent spring with K equivalent for its spring constant. So let's say that we exert a force on this block F that compresses these springs a distance delta x. So we have F equals K equivalent times delta x. So let's say that this spring compresses a distance xl and this one a distance xr. So we see that this spring must exert a force of K delta xl, and this spring exerts a force of K delta xr. And by Newton's third law, these are equal. So we find that delta xl equals delta xr. So essentially, what we have is that both of these combined make delta x. So we have that delta xl equals half delta x. So then what we go from there is that we see that the right spring doesn't exert a force on the block. It is the left spring that exerts a force on the block. And it exerts a force K times delta xl, which is equal to K equivalent times delta x. And we see that delta xl plus delta xr equals x. And because these are equal, we see that delta xl should be equal to half x. So we see that K times half x equals K equivalent x, to find that K equivalent is half K. So from there it's very simple. We take our equation of frequency for simple harmonic motion, which is 1 over 2 pi times square root K over m. So we have 1 K equivalent. So we have 1 over 2 pi times the square root of K over 2m. And if we plug in our numbers, this gives us 1 over 2 pi times the square root of 6,430 Newton per meter over 2 times 0.245 kilograms. And if you plug all that into your calculator, you should get that your frequency is 18.2 hertz. Thank you for watching. I hope you learned something about equivalent spring constants. Please like the video, subscribe to the channel, and I will see you later. Bye!